We're going to take a look at Extrema on an interval. Now you can also find more math and computer science YouTube videos, links to them that is, under this website, mathheals.com. Now this just starts talking about extrema. We'll look at relative extrema in another lesson. This first problem asks us to find any critical numbers. So let's take a look at it. We got f of x is equal x to the fourth minus 18x squared. Now, a critical number is different based upon what you're trying to find. Critical number means something important possibly is happening there. So let's take a look at this one. Specifically, when they're talking about the critical numbers here, they're talking about for extrema. So finding critical numbers. Well, step one. Find the derivative. So for this one, the derivative, again, we got x to a power, so take your power, put it up in front, lower it by 1. So that gives us 4x to the third, minus 18. Take your power, put it up in front, lower it by 1. So that gives us 4x to the third, minus 36x. Step 2, set this equal to 0. And solve. Now we're going to see when we have a fraction, we'll do that a little bit differently. So we'll set that equal to 0. So we got 4x to the third minus 36x equal to 0. And we're going to factor out the GCF, greatest common factor. They're both divisible by 4, and they both at least have one x. So that 4 is gone. One of those x's is gone, so that leaves us x squared here. Minus 36 divided by 4 is 9, and that x is gone. Well, now we're going to factor this using the difference two squares. Two terms of minusing it. X squared minus 9 becomes x plus 3 times x minus 3. Now the zero factor property from college algebra says if you get 0 on one side and you factor the other side, you set each factor equal to 0. So I got 4x equal to 0, x plus 3 equal to 0, and x minus 3 equal to 0. Then you solve each one. This one I'm going to divide both sides by 4. And we get x equals 0. This one we take the 3 over, becomes a negative 3. This one taking negative 3 over becomes a positive 3. And these three right here are critical numbers, where possibly something's happening. Let's look at this one. This one doesn't start out with a fraction, but it'll have one in it. Hopefully I have room for it on here. First off, we want to rewrite the cube root in rational exponent form, fractional power. So we'll write that as x minus 2 to the 1/3. Remember, whatever number is in your slot here goes in your denominator, and then 1 up on top. Well, to find the derivative of this is going to be the product rule. So this will be p, and this will be q. P prime, derivative of x squared is 2x. Q prime, the derivative of x minus 2 to the 1/3. We got parentheses to a power. This is a chain rule, specifically a general power rule. We'll take our power, put it out in front. What's inside the parentheses remains as is. We'll lower our power by 1. And then we'll multiply it times the derivative of what's inside the parentheses. Well, the derivative of x minus 2 is 1, so that drops away. And this gives us 1/3 x minus 2 to the negative 2/3. And we're going to take that x negative 2/3 down to the denominator, so it becomes x minus 2 to the positive 2/3. Okay. Product rule, we got p prime q plus p q prime. So for our derivative, we said p prime was 2x times q, which is x minus 2 to the 1/3, plus p, which is x squared, times q prime, which is 1 over 3 times x minus 2 to the 2/3. Double check all that. Yeah. And now we need to do a little bit of simplifying. I'm going to rewrite this as 2x times x minus 2 to the 1/3 all over 1 plus x squared over 3 times x minus 2 to the 2/3. Now we want to get a common denominator, and since this one's 1, our common denominator is the other one. So we're going to rewrite each of them with this new denominator. 3x minus 2 to the 2/3 Well, on our first fraction here, I multiplied the bottom part by 3 times x minus 2 to the 2/3, so I have to multiply the top part by it. So times 3 times x minus 2 to the 2/3. Now our second fraction we didn't have to do anything with, so it stays as is. And I'm going to continue it up above. Well, in this first fraction here, we got 2x times 3, that gives us 6x. We also have x minus 2 to the 1/3 times x minus 2 to the 2/3. Since these are both x minus 2 to a power, I can add the exponents. 1/3 plus 2/3 gives us 1. So that gives us x minus 2 to the first power. Plus, second fraction is just an x squared. So x squared over 3 times x minus 2 to the 2/3. By the way, we're still on step 1 here, find a derivative. Okay, 6x times, actually, I'll go ahead and merge them into a single fraction first, because actually I see something. Sometimes it's beneficial for you to go ahead and get rid of parentheses, sometimes not. What I saw is this is my first group, this is my second group. Why these are grouped together is because this is 6 times x minus 2, everything's multiplication, and this is x squared, x times x. If I look at these groups, they have an x in common, so I'll factor that out. And that leaves me 6 there times x minus 2 plus x. So factor out GCF. Then I got x times 6 times x is 6x. 6 times negative 2 is negative 12 plus x over this. Which gives us 7x minus 12 inside the parentheses. Okay, now we're ready for step 2. Now step 2 says set it equal to 0 and solve it. Well, that's what we do. But when you have a fraction, you not only look where it's equal to 0, but you look where it's undefined. So we're going to set the top part equal to 0. So I'll set the x times 7x minus 12 equal to 0. And we'll set the denominator equal to 0. So 3 times x minus 2 to the 2/3 equal to 0. Now this side here is already factored, so we just have to set each factor equal to 0. So I set x equal to 0 and 7x minus 12 equal to 0. That one's solved. Here I'll take the negative 12 over, it becomes a positive 12. Divide both sides by 7. And we get x is equal to 12/7. Now in this one, whenever you have parentheses and then you got 0 on the other side, if there's a power and there's a number out in front, assuming they're just numbers, then you can set whatever's inside your parentheses equal to 0. So I'll set x minus 2 equal to 0, which gives us x is equal to 2. So those would be our 3 critical numbers. That one wasn't too easy. Radicals never are, though. So what's this section called? Extrema and an interval. So let me save this page. And there we go. Calc 1 Extrema on an interval, page 01.pdf. There we go. And let's go down to our next problem. Grab a drink here. This one's working on the fraction. Starts out as a fraction. We got f of x is equal to x plus 2 over x minus 5. Same instructions, find the critical numbers. Well, this is going to be the quotient rule. So the top part is p, the bottom part is q. I need p prime. Well, the derivative of x plus 2 is 1, and I need q prime. The derivative of x minus 5 is 1. Quotient rule, our formula is p prime q minus p q prime over q squared. So for our derivative, we'll have p prime, which is 1, times q, which is x minus 5, minus p, which was x plus 2, times q prime, which is 1, over q squared, which is x minus 5 squared. Those ones really don't do anything, so I can drop those. So we got x minus 5. This is step 1, by the way. Now here, this 1 drops away, but the negative that's in front of our parentheses flips the sign of everything inside. So this becomes a negative x minus 2 all over x minus 5 squared. Well, x minus x drops away. Negative 5, negative 2 is negative 7 over x minus 5 squared. Well, step 2. Set top equal to 0, set the bottom equal to 0. So we'll set negative 7 equal to 0, and we'll set the x minus 5 squared equal to 0. Remember, if you have a fraction, you set your top part equal to 0, set your bottom part equal to 0. Now, the negative 7 equal to 0, there is no variable to solve for here, so I can just cross that out. Actually, whenever you just have a single number, you never need to worry about setting that equal to 0, because it never goes anywhere. Now, remember what I said. If you got parentheses, and you got 0 on the other side, and then you got powers, numbers out in front, you can just set what's inside the parentheses equal to 0. We'll use that over and over. And we'll get x is equal to 5. And that's our critical number. Now actually, our graph is not defined to 5. If I put that in my original function, I get 5 minus 5, which is 0. That does not matter. Something could still be happening there, even though the graph doesn't exist. Let's take a look at this one. I'll start it here. Get f of x is equal to sine x plus cosine squared. From 0 to 2 pi, not including 0 and 2 pi. Well, first off, this is sine x plus cosine x to the second power. That's what that means. So to find our derivative, step 1, derivative of sine is cosine. Now here we have a parentheses to a power. This is the chain rule, the general power rule specifically. If you got parentheses to a power, you take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. And then you multiply it times the derivative of what's inside the parentheses. Again, take your power, put it out in front. What's inside your parentheses remains as is. Lower your power by 1 times the derivative of what's inside the parentheses. So we got cosine x plus 2 cosine x. And the derivative of cosine x is negative sine x. So this becomes cosine x, I can put the negative out in front, minus 2 cosine x sine x. Step 2, we want to set this equal to 0. So we've got cosine x minus 2 cosine x sine x equal to 0. Now I notice that they have something in common. They both have a cosine. So I'll factor out cosine, and that leaves me a 1 there, minus 2, then the sine x equal to 0. Well, zero factor property from college algebra, you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set cosine x equal to 0, and I'll set 1 minus 2 sine x equal to 0. Now here I'll take the negative 2 sine x over, so I got 1 equals positive 2 sine x. We're trying to get sine by itself. And then we'll divide both sides by 2. And we get sine is equal to 1/2. Okay, here at 0, we got the point, haven't woke up yet this morning. Why am I drawing that one? Okay, up here. This is pi over 2. We have 0 and 1. And down here at 3 pi over 2, this is on our unit circle, we have 0, negative 1. Now, we got cosine is equal to 0. So we're going on a unit circle, and we're looking where cosine is equal to 0. Now, cosine is the x part of our unit circle. So if I look at the x part, it's equal to 0 here at pi over 2. It's also equal to 0 down here at 3 pi over 2. Excuse me. So those off the cosine. I did that a little bit high, but I wanted to make sure I had room. If we look at pi over 6, that's going to be the point. Square root of 3 over 2 and 1/2. And if I look over here at 5 pi over 6, this is going to be negative square root of 3 over 2 and 1/2. So on this one, we're looking where sine is equal to 1/2. Sine is our y on our unit circle. So if I go around the unit circle, I'm looking where y is equal to 1/2. It's equal to 1/2 here at pi over 6. It's also equal to 1/2 over here at 5 pi over 6. So those would be our 4 critical numbers for that problem. I think this is the last, this is the last critical number 1. Then we'll look at the next item. We got f of x is equal to x squared e to the 3x. Well, this is the product rule again. We got something times something else. So this will be our p, and this will be our q. We need p prime. The derivative of x squared is 2x. And we need q prime. The derivative of e to a power is e to the power times the derivative of the power. Chain rule. Well, again, the derivative of e to a power is e to the power. That doesn't change. Times the derivative of the power. Well, the derivative of 3x is 3. So we got 3e to the 3x. Our formula for the product rule is p prime q plus p q prime. So for our derivative, p prime was 2x times q, which was e to the 3x, plus p, which was x squared, times q prime, which is 3e to the 3x. Now, I notice they both have an e to the 3x, so this is still step 1. I could factor out what they have in common. And they both have an x, so I can factor that out. That x is gone, that e to the 3x is gone, so that leaves us 2. Plus, that 3 is still there. That e to the 3x is gone, and one of these x's is gone, so that leaves us a single x. Okay, step 2. Set this equal to 0 and solve it. So we got e to the 3x times 2 plus 3x equal to 0. Well, this is already factored. We got e to the 3x times 2 plus 3x. So we're going to set each factor equal to 0. So I'll set e to the 3x equal to 0. I'll set x equal to 0. And I'll set 2 plus 3x equal to 0. Well, let's first start with the e to the 3x. This is an exponential equation. Exponential equation is where you have a variable up in the exponent. And our steps for solving an exponential equation is get the part with the variable and the exponent by itself. No numbers in front of it, no numbers after it. Well, this is by itself. There's no numbers in front of it, no numbers after it. Step 2 is to take natural log of both sides. But when I take natural log of both sides, I see I get natural log of 0, which you can't have, so there are no critical numbers from that one. Actually, when you have a number, and e is just a number, if you put down your calculator, 2.7, bunch of decimal places. If you have a number to a power equal to 0, that's never going to be equal to 0. Well, this one's already solved for x, so we're good there. On this one, I'll take the 2 over, becomes a negative 2, then divide both sides by 3, and we get negative 2/3. So those are our two critical numbers. Let me save this. And let's look at our next problem. Got f of x is equal to 2x to the third minus 6x, 0 to 5. And it's asking us to find locate the absolute extrema of the function on the closed interval. Find the highest point and lowest point. That's what absolute extrema means. Well, let's take a look at our steps. And let's just generally talk about where we're headed with this. Your absolute extrema, your highest point or your lowest point, happens at either at the endpoints, so it would happen at 0 or 5 on this, or it happens at a critical point. So that's what one of the things a critical point tells us. So you can kind of imagine where we're headed with this. Then our first step is to find derivative. So the derivative of this, take your power, put it out in front, lower it by 1, minus, and then you got a number with an x, the x just drops away, so we got minus 6. So that gives us 6x squared minus 6. Step 2. Set this equal to 0 and solve. And this, of course, gives us our critical numbers, which we saw from earlier. And I'm going to say exclude any critical numbers not in your interval. Well, we're looking from 0 to 5 on this problem. So any critical values that are not 0 to 5 we want to exclude. Okay, so let's set this equal to 0. 6x squared minus 6 equal to 0. Now they have a GCF. They both have a 6, so I can factor that out. And that gives us x squared minus 1. What's inside of parentheses is difference two squares. So it factors as x plus 1 times x minus 1. Now it doesn't do us any good to set the 6 equal to 0, because again that's just a number. So we'll set the x plus 1 equal to 0, and we'll set the x minus 1 equal to 0. So we get x is equal to negative 1, and x is equal to positive 1. Now these are our critical numbers. Remember what I said though, exclude any critical numbers not in the interval. We're going from 0 to 5. 1 is from 0 to 5, but negative 1 isn't. So we want to cross that one out. We're not going to use that. And again, this we found was our critical numbers. Step 3. Plug in the remaining critical numbers and the endpoints into the original function. Your largest value will be your absolute extrema. Specifically, your absolute max. Your smallest value will also be your absolute extrema. Specifically, your absolute min. Extrema is just another word to represent your mins and maxes. Okay, well, our endpoints. We got x is equal to 0. We got x is equal to 5. Those are our two endpoints. And the critical number we have left is the 1. So we're going to take those and plug them into our original function. Our original function was this. So we're plugging in f of x is equal to 2x to the third minus 6x. Plug it in here too. So 2x to the third minus 6x and 2x to the third minus the 6x. I'm not going to do all these by hand. We'll use the TI3, TI4 calculator to make this a lot easier. So f of 0 is going to equal to 2 times 0 to the third minus 6 times 0. Well, 0 to the third is 0, times 2 is 0. 6 times 0 is 0. 0 minus 0 is 0. On this one, I'll plug in 5. So we got f of 5 is equal to 2 times 5 to the third minus 6 times 5. 5 to the third is 125. 5 times 5 is 25 times another 5 is 125 minus 30. 6 times 5, which gives us 250 minus 30 equals 220. And then f of 1. We got f of 1 is equal to 2 times 1 to the third minus 6 times 1. 1 to the third is 1 times 2 is 2 minus 6 times 1 is 6, so that gives us a negative 4. Assuming no basic math error, these are our three values. Now it says your largest value is your absolute max. So this right here would be our absolute max. If we were to write it in point form, it'd be 5 and then 220. Now this negative 4 is my smallest value. So this will be our absolute min. If I write it in point form, it'd be 1, negative 4. Now let me show you how to use your calculator to do this, because that's what we're going to do the rest of them with. Much as I like doing basic math on a Saturday morning, I'll probably make a basic math error if I do. So we're going to let technology do it for us. Okay. First off, I'm going to go to y equals and clear out anything I have on y1, y2, or whatever lines. And on y1, we want to put in our function, which was 2x to the third minus 6x. So we've got 2x caret 3 minus 6x. Now we won't go to our table settings. So I'm going to do second window. Now, if you followed the earlier lessons, you probably already have this set. But if you don't, you see where it says independent? You want to down arrow to that line. Right arrow, put your flashing cursor on the ask, and press enter one time. You want it to say ask. Now you only have to do that one time. It stays that way from here on. Now do second graph to go to my table. Now you probably don't have any numbers here. I do from a previous problem. Let me go ahead and press delete to clear those out. Now I got my function in y1, so now I'm going to plug in 0, 5, and 1. So 0, inner, 5, inner, and 1, inner. And you see you get 0, 220, and negative 4. So 0, 220, negative 4. And I guess I didn't make a basic math error. And no, these two right here are our answers, because it was asking for absolute extrema. Let's take a look at another problem. I'm going to start a new page, just to make sure I have room for this. So let me save this. Okay. Got f of x is equal to x over x plus 5, 2 to 5. Now, there's some additional items you have to consider when you're dealing with fractions. Of course, finding our critical numbers is different. We already know that. But if we find any critical number that causes the denominator to be 0, we can't have that. So we would exclude that. Doesn't really matter in this problem, because the value that causes 0 in our denominator would be a negative 5. If I put negative 5 plus 5, that gives us 0 here. But negative 5 isn't in our interval. So again, it's not an issue on this problem. What's something to keep in mind? Well, this is a quotient rule. Top part is p, the bottom part is q. P prime, the derivative of x is 1. Q prime, the derivative of x plus 5 is 1. So our quotient rule is p prime q minus p q prime over q squared. So for our derivative, we got p prime, which is 1, times q, which is x plus 5, minus p, which is x, times q prime, which is 1, all over x plus 5 squared, q squared. Well, these ones drop away, so we got x plus 5 minus x over x plus 5 squared. Well, up on top, x minus x drops away, and we got 5 over x plus 5 squared. And that's our derivative. Well, step 2. Find our critical numbers. Set top part equal to 0. Set the bottom part equal to 0. We don't need set the 5 equal to 0 because it's just a number. But we'll set the denominator equal to 0. So x plus 5 squared equal to 0. Remember what I said. If you have parentheses to a power equal to 0, you can just set what's inside of parentheses equal to 0. And we get x is equal to negative 5. Now this is our critical number, but it's not in our interval from 2 to 5. So that's not even something we're going to look at. So we're going to plug in our endpoints. Plug in 2, and we'll plug in 5. And this one's so easy, I'm not going to type it in my calculator. So f of 2, I'm plugging in my original function. Everywhere I have an x, I'll put in a 2. So I got 2 over 2 plus 5, which gives us 2/7. And f of 5, I put in 5, and I got 5 over 5 plus 5, which gives us 5/10, which gives us 1/2. So our smaller value is this one right here. So this is our absolute min. When I say smaller value, I'm talking about which ones you find right here. The 2/7 versus 1/2. So absolute min at 2 and 2/7. And this one will be our absolute max at 5 and 1/2. Now the flaw of using the calculator is if you're trying to get the exact value, it'll tell you what the values are, which works very well with polynomials, but we won't give it to you in fraction form, so it'll give you in decimal form, which isn't what we're looking for. Now some of these you can look at and kind of see what they're referring to. If I look at x over x plus 5 and graph it, so I go to y equals, clear. I'll do my x key divided by, and I had to put parentheses around the bottom part because we have more than a single term down there, or a single variable or single number. So put a beginning parentheses, x plus 5, closing parentheses, and then graph. You can see over here -5 is where it's not defined. And then in 2/2, we're looking from 2 to 5. You can see it's going up as it goes from left to right. So it's obvious that this is absolute min, this would be absolute max. Okay, so let's look at our next one. Got f of x is equal to -2 sine x. 0 to 2 pi. Now step 1, find our derivative. -2 just carries down, and derivative of sine is cosine. Step 2, set this equal to 0. So I got -2 cosine x equal to 0. And I could divide both sides by -2. And we get cosine x is equal to 0. If I look at my unit circle, here at pi over 2, we have the 0.01, and here at 3 pi over 2, we have 0, -1. Cosine on our unit circle is the x part, so if I look around my unit circle on my points, where x is equal to 0, it's pi over 2, and it's 3 pi over 2. Now if I check, both of those are in the interval from 0 to 2 pi. So we want to include both of those. Well, now I want to plug in, doesn't matter what order actually. Let me plug in pi over 2 into my original function. And I'm going to find the doesn't matter. No, it doesn't matter. You could actually use table, but this is so easy, I'm not going to bother. F of pi over 2 will hopefully eventually get some hard ones where it actually makes a difference. Original function was -2 sine x, so we got -2 sine of pi over 2. And at pi over 2, our sine, which is our y, is 1. So this is -2 times 1, which gives us -2. At our other critical number, critical point, 3 pi over 2. We got f of 3 pi over 2 is equal to -2 sine of 3 pi over 2. Here at 3 pi over 2, sine, which is our y, is equal to negative 1. So I got negative 2 times negative 1, which gives us a positive 2. Add our endpoints. The first one, 0. F of 0 is going to equal to negative 2 sine of 0. And if I look at sine of 0, here's 0 here. This point is 1, 0. And the other place, oops, I don't use pi. The other place is 2 pi. This is also, besides 0, this is 2 pi. But if I look at sine, which is our y part, sine is equal to 0. So this is negative 2 times 0, which is 0. And at our other one, at 2 pi, f of 2 pi. We know f of 0 and f of 2 pi are the same, but if I plug it in, I get negative 2 sine of 2 pi, which gives us negative 2 times 0, which gives us 0. Smallest value is this one right here. So this is going to be our absolute min at pi over 2, negative 2. This one's our largest value. So this is going to be our absolute max at 3 pi over 2, 2. And those would be our answers. Save that. And we'll grab a drink, and then we'll look at our next one. Okay, so we got f of x is equal to cosine pi x over 4 intervals from 0 to 8. First step, find derivative. Derivative of cosine is negative sine, so this becomes negative sine pi x over 4. But since this is more than a single x here, you have to then multiply it times the derivative of what's inside your parentheses. Chain rule. So that gives us negative sine pi x over 4 times, and derivative of pi x over 4, the pi over 4 would disappear, or the x would disappear, and we'd just be left with pi over 4. I better wake up here. Can't do a simple derivative. So that's negative pi over 4 sine pi x over 4. Step 2, set that equal to 0. So I got negative pi over 4 sine, then pi x over 4 equal to 0. Now I could divide both sides by negative pi over 4, and it would disappear. It's just a number. So we're left with sine of pi x over 4 is equal to 0. Now since this is more than just a single x here, we can't look it up on our unit circle direct. What we're doing is we're looking where sine of something is equal to 0. And we're looking where sine of something is equal to 0. Well, if I can start going around my unit circle, here's one place at the angle 0. That's sine is equal to 0 there. Over here at pi, this point is negative 1, 0. Sine, which is our y, is also equal to 0. Now I don't know how many we'll need exactly. Let's start there and then build upon it. Whenever you have more than a single x, you have to take what's inside the parentheses here, the pi x over 4, and set it equal to what we just found here. So we got pi x over 4 is equal to 0. And we'll take the pi x over 4 and we'll set it equal to what we found right here. So pi x over 4 is equal to pi. Well, let's see what these give us and then see if we need to go further. Here I multiply both sides by 4, and I'd get pi x is equal to 0. Divide both sides by pi, and 0 divided by pi is 0. So we get x equals 0. Over here, I multiply both sides by 4, and I get pi x is equal to 4 pi. And then divide both sides by pi, and I get 4 pi over pi. The pi's would cancel, and I'd get x equals 4. Now we're looking from 0 to 8. So we got 0, we got 4. I need to do one more, maybe two more. But let's see. Now, here at 0, sign is equal to 0. Here at pi, sign is equal to 0. If I keep going around 2 pi, it's also equal to 0. Basically, whatever angle you had right here, you're just going to add 2 pi to it. And that will also equal to 0. This one would do the same thing. I don't think we need that one, but let me go ahead and show it. This one we got pi, and we'll add 2 pi. And that also gives us 0. Because remember on our unit circle, whenever we add 2 pi, we're back to where we started. So by default, it has to be the sign has to be equal to 0 there also. So this is sine of 2 pi is equal to 0. And this one, pi plus 2 pi gives us 3 pi is equal to 0. Now again, we're going to take the pi over x over 4 and set it equal to each one of these. So I got pi x over 4 is equal to 2 pi. And pi x over 4 is equal to 3 pi. On this one, I'll multiply both sides by 4, and we get pi x is equal to 8 pi. Now I divide both sides by pi, and we get x is equal to 8. Now this one, multiply both sides by 4, and we get pi x is equal to 4 times 3 pi is 12 pi. Divide both sides by pi, and you get x is equal to 12. How do you know when to stop? Like I could keep adding 2 pi over and over. I could do this for the rest of my life and still not be done with this problem. Well, you know when to stop when the value you come up with exceeds the larger value in your interval. See, we're only looking from 0 to 8. But if you look at 12, well, that's greater than 8, isn't it? Which means we don't want that one. We don't need to do any past that. So these are our 3 critical values. Now there's a problem with them. If I look back at my original function, original problem, I'm looking from 0 to 8. Well, this critical value and this critical value are my endpoints, aren't they? So I don't even need to worry about those. They get handled with the endpoints. But we're going to plug in 0, plug in 4, and we'll plug in 8 into our original function. What was our original function? F of x is equal to cosine of pi x over 4, so pi times 0 over 4. Well, pi times 0 is 0. 0 divided by anything is 0. So we get cosine of 0. Now this one. If I plug 4 in for my x, I got cosine of pi times 4 over 4, which those 4's would cancel and gives me cosine of pi. And those aren't f of x. Not that it matters, but this should be f of 0, and this should be f of 4. This one, I'm finding f of 8. So I'll plug 8 in for my x, and I got pi times 8 over 4, which is 8 pi over 4, which is 2 pi, so I got cosine of 2 pi. If I look at my unit circle at 0, this is 0, it's also 2 pi. This point here is 1, 0. If I look over here at pi, this point is negative 1, 0. So cosine of 0. We come here to 0, and cosine is our x part, which is 1. Cosine of pi, well, that's over here, and cosine is our x part, which is negative 1. And back to 2 pi, we're over here, which is again equal to 1. Now, this one right here is our absolute min. It's our smallest value, and occurs at 4, negative 1. Now our absolute max, we actually got two values of the same, the ones. So absolute max, we have two of them. It occurs at 0, 1, and at 8, 1. And that's our answer. Let's save that. It's raining here. I hear thunder, lightning. Worries that my power's going to go out, and then no. Just when I'm just about ready to get done with this video, won't be finished. Of course, the time it'll happen will be when I'm on the very last problem here. Wasn't for bad luck, I'd have no luck at all. Let's see. Natural log of x over x squared from 0 to 4. Now notice the 0 has a parentheses on it, so it doesn't include that because actually our graph doesn't exist at 0. But there's a bracket on the 4, so we're only going to have one endpoint here. Now this is a quotient rule, so let top part be p, let the bottom part be q. The derivative of natural log of x is 1 over x. Q prime, the derivative of 2x, or x squared, is 2x. So our formula is p prime q minus p q prime over q squared. So for a derivative, p prime was 1 over x times q, which is x squared, minus p, so minus natural log of x, times q prime, which was 2x, all over q squared. Let me double check that. P prime times q minus p q prime. Okay, that's right. 1 over x times x squared gives you x squared over x, or just x, minus, and I'll put this 2x out in front, natural log of x. And down here, when you raise one exponent to another exponent, you multiply them together, so 2 times 2 gives you 4. Now I'm going to factor an x out of the top, the GCF, and that leaves you 1 minus 2 natural log of x over x to the fourth. Now here we have an x, and here we have an x to the fourth, so we can cancel this x and one of these x's. So we're going to have 1 minus 2 natural log of x over x to the third. That was step 1. Step 2, we need to find our critical numbers. We've got a fraction, so we're going to set the top part equal to 0 and the bottom part equal to 0. So I got 1 minus 2 natural log of x is equal to 0, and x to the third is equal to 0. Now first off, I'll start with the x to the third equals 0. Whenever you have x to a power, again, you can just drop the power and set the x equal to 0. Got a problem with that one, though. We said that our interval doesn't include 0. Remember the parentheses here on the 0? Which means that I'm going to just cross that one out. Can't use that one. Now here, this is a natural log equation, log equation. Our steps for solving a log equation said get everything with a log on one side, numbers on the other side. So I'll take that negative 2 natural log of x to the right side. Becomes a positive 2 natural log of x. Now our second step said you use properties of logs or basic math to get the log by itself. So I divide both sides by 2. Now remember, when you got natural log, that's base e. And I'll put it there, even though it's technically incorrect to put it there, just to really emphasize the next step. Our next step is you take your base to a power of the other side equals what follows your log. Our base is e, so we'll take e to a power of the other side equals what follows your log. The question is that in the range 0 to 4? So if I plug that in my calculator, e to the 1/2, exit out of the graph, and I'll do e, which is second ln, and then 1 divided by 2, gives us 1.65. So it is indeed in that that interval. And I'll do step 3 over here because I'm afraid I'm running out of room. The one critical value we have is e to the 1/2, so I'm going to plug that in. And from our interval here, I don't use 0, but I'm going to use 4. So we'll plug in 4. And we're going to plug that into our original function, whatever that was. Natural log of x over x squared. So natural log of x over x squared. So here, this becomes natural log of e to the 1/2 power over e to the 1/2 squared. So let me write that. F of e to the 1/2. Everywhere we have an x, we put an e to the 1/2. Here, I'm going to be plugging in 4. So I'm going to have natural log of 4 over 4 squared. Now remember in your properties of logs, when you got the base, in this case natural log is base e, when you got your base here matching whatever is here, then the log and the base and the e are going to cancel and leave you the 1/2. So we've got 1/2 over, and when you're raising one exponent to another exponent, you multiply them together. 1/2 times 2 is 1, so that just gives us e. So this gives us 1 over 2e. I need to know approximately what that is to see if that's my max or min. So let me come over to my calculator. I do 1 divided by, parentheses around the bottom part because we've got more than a single number down there, and then 2e. Now to get to single e, just do second divide. And that gives us 0.18. Now in this one, this gives us natural log of 4 over 16. And let's see what that's equal to. So natural log of 4, close parentheses, divided by 16, 0.09. Which means this is my lowest value, so this is my absolute min. And that occurs at 4, then natural log of 4 over 16. And this one is our absolute max. This is our larger one. And it occurs at e to the 1/2. And then 1 over 2e. And those would be our answers. Let me save that. I think that was the last problem. Yes, it was. So let me save all of this.